And we're back. Week 11, day 4. We're going to be talking about derivatives of trig functions. Okay, out of these videos I've made so far, I'm going to go ahead and state that this one's probably going to be your most important. Okay, it's going to be something you will definitely see. Starting off, these are going to be derivatives that you need to know. Okay, if you start off with y is equal to sine of x, your derivative will be cosine of x. If you start off with cosine of x, your derivative will be negative sine of x. Okay, these are two derivatives you must know. Let's make this again. Must know these. It is a requirement. It's everything you need to know is derived from these two derivatives. Okay, you can figure out any other derivative in working with trig functions as long as you remember these two. Okay, so starting off pretty light here. Taking the derivatives, it's working real nice. You can still pull out a constant just like any other derivative. So here we're going to get y prime is equal to 3. The derivative of sine of x is cosine of x. Okay, easy enough. This one, if you want to, you can rewrite it to be 1/2 times sine of x. So our y prime will still just be 1/2 times cosine of x. If you wanted to rewrite that again, just cosine of x over 2. Okay, easy peasy right there. And then our third one here, we're going to get that y prime is going to be equal to the derivative of x, which is 1, plus the derivative of cosine of x, which is negative sine of x. So if we were going to rewrite that, we would have y prime is equal to 1 minus sine of x. Okay, again, nothing too bad here, just some very basic derivatives, knowing that you know your two trig derivatives. Okay, so in this case, we're going to take the derivative of this function here. Now this function doesn't look very nice, but it's actually pretty nice. Okay, it's going to work out. We're going to use the product rule. Okay, our product and our quotient rules are going to work just the same even though we're working with trig functions. Okay, in this case we have two pieces here, and in this case it's just 1. Okay, so for our derivative, let's take the derivative of 2x first. So we're going to have 2, leave the second part, so cosine of x. We're going to leave the first part, and multiply by the derivative of the second, which is going to be negative sine of x. And then we're going to take the derivative of negative 2 sine of x, which will give us negative 2 cosine of x. Now we're just going to combine some like terms. So we're going to have 2 cosine of x minus 2x sine of x. And then we're going to have minus 2 cosine of x. Like I was saying, like terms there and there. Y prime is only going to be left with negative 2x sine of x. And that's our derivative. Okay, looking real nice there. Okay, similarly, you're able to find a slope. To be able to find a slope, you need to first find the derivative. Okay, so we need to find f prime of x. F prime of x, if we're starting off with 2 cosine of x, is just negative 2 sine of x. Okay, the constant's pulled out. Derivative of cosine of x is negative sine. Now to find our slopes, we're just going to plug in the x values. Okay, so we're going to plug in the x values. So f prime of negative pi over 2 is going to be negative 2 times sine of negative pi over 2. That's going to go ahead and give us negative 2 times negative 1, which is just going to be 2. Okay, so the slope at this point along the derivative will be 2. Okay, for our next one, we're going to go ahead and find f prime of pi over 3. Okay, notice how I'm not using this 1. We're not using the 1 because there is no y value here. Okay, we have a y prime, but there is no y value. So we're just going to go ahead and continue what we were doing. Negative 2 times sine of pi over 3. That's going to give us negative 2 times root 3 over 2. Okay, and that's going to go ahead and simplify to be negative root 3. So our slope at this point along this line, our instantaneous rate of slope, or our derivative, is going to be negative root 3. And then for our last one here, let's use a different color. Let's go ahead and have f prime of pi. We're going to get negative 2 times sine of pi, and as we should know, sine of pi is going to go ahead and be 0, so it's negative 2 times 0, so our slope at that point is just 0. Okay, here comes the next bit. So we're going to have 4 derivatives that you're going to need to know. Now, do I expect you to memorize these? I would probably expect you to memorize this one. Okay, so derivative of tangent of x is going to be secant squared of x. Now the rest of these are going to be able to be figured out. Okay, so again, if you need to write these down somewhere, write these down. You could always pause the video now, probably a good bet, but we're going to go ahead and move on. All of these can actually be found using the quotient rule. So if you have, let's see where my pen go, y is equal to tangent of x. Now we should all know by now that this is the same thing as sine of x over cosine of x. And using the quotient rule, we're going to be able to take the derivative of this. So it's going to be low d high, our derivative of sine of x is cosine of x. We're going to subtract low d high minus high, so sine of x, d low, which is going to be negative sine of x. And this is all over low, so cosine squared of x. Now if we simplify this, this is going to go ahead and be cosine squared x plus sine squared x over cosine squared x. This right here on our numerator is one of our special trig identities. This is going to leave us with 1 over cosine squared x, which is lovely because this is going to give us secant squared x. This will work for all of those functions I was talking about a second ago, so it'll work, oops, wrong button. It'll work for this one, it'll work for this one, this one. It works for every single trig function that you're going to have some kind of denominator in. You could always just use the quotient rule to find it. If you want to, definitely worth the time to just memorize them. So if we're going to go ahead and find the derivatives here, use it looking at our first one. We have y equals x minus tangent of x, so y prime is just going to be the derivative of x, which is 1, minus the derivative of tangent of x. So we're going to minus secant squared of x. Okay, real nice. For y prime here, we're going to go ahead and use the product rule. We have 2 pieces here. Okay, so let's go ahead and take the derivative of the first one, leave the second part. Oops, and we're going to add, leave the first part. The derivative of secant of x is secant x tangent of x. Okay, so we're just going to go and simplify. We get secant x plus x secant x tangent x. And I'm going to factor out a secant of x. So I get secant x times 1 plus tangent of x times x. Okay, nothing too bad. Keep moving on here. So as you can probably see, we're going to use a lot of our trig properties, our trig identities, and a lot of our derivative rules now to be able to find the derivatives of these kinds of trig functions. So we're going to find the derivatives of these 2 functions here. Looking at our first one, we're going to go ahead and use our quotient rule. So that y prime is going to be low d high. Our derivative of this is going to be sine of x. Okay, you may be thinking, wait, that's cosine. Shouldn't it be negative sine? It's actually negative cosine, so its derivative is just going to be positive sine. We're then going to have minus high d low. So we have 1 minus cosine of x, and the derivative of the low is cosine of x. And this is all over low, so sine squared of x. We're just going to go ahead and simplify some stuff here. So we have sine squared x minus, we have cosine of x minus cosine squared of x all over sine squared of x. We're just going to do this again. We have sine squared of x minus cosine of x plus cosine squared of x all over sine squared of x. And lucky for us, we have a cosine squared x and a sine squared x, so that just gives us 1. And our derivative here is going to be 1 minus cosine of x over sine squared of x. Okay, over here, we're just going to go ahead and find each of these pieces individually. Now, if we can remember our trig function derivatives, this is actually going to be really easy. Okay, the derivative of cosecant of x is negative cosecant x, cotangent of x. Oops, it's supposed to be a c. And then we're going to subtract the derivative of cotangent of x. Now, the derivative of cotangent of x is negative cosecant squared x. So if I was going to go ahead and simplify this derivative to now be negative cosecant x cotangent x plus, that's supposed to be a squared, sorry, cosecant squared x. And that's our derivative. Okay, so if we can remember those derivatives, it really does make our life a lot easier. Okay, you may be thinking, okay, we've done some product rule, we've done some quotient rule. Can we guess what's next? If you guessed chain rule, then yes, you did. Okay, it's going to work the same as every other derivative that we've ever done. Okay, you can set, in this case, u to be equal to 2x, so that you have y prime is going to be, actually I'm going to go ahead and erase that real quick. So we're going to get that y is sine of u, so that y prime is cosine of u times du. So we're going to go ahead and get that this is going to be cosine of 2x times the derivative of 2x, which is 2, which leaves us with 2 cosine of 2x. And that right there is our derivative. Okay, for our next one, same kind of thing, except for I'm just going to kind of skip the setting u equal to something. I'm going to go ahead and get that y prime. So do the stuff here. Derivative of cosine is negative sine. Keep the stuff on the inside, x minus 1. We're going to multiply this by the derivative of the inside. Now our derivative of the inside is just 1. So this is just going to give us negative sine of x minus 1. Okay, that is our derivative there. Last one here, we're going to go ahead and get that y prime. Now the derivative of tangent of anything is going to be secant squared. We're going to keep our value of u to be e to the x, and then we need to multiply by the derivative of u. In this case, our u is e to the x, so our derivative here is going to be e to the x times secant squared e to the x. Doesn't look very nice. Try that again. Secant squared e to the x. There we go. That's our derivative. Okay, we're wrapping things up here. Got a couple more derivatives we're going to go through. Okay, so we've got 4 derivatives here. In this case, we're just going to go ahead and do the same thing we were just doing. So if we have y is equal to cosine of 3x squared, y prime, see the derivative of cosine is negative sine. We're going to keep the stuff on the inside, so 3x squared. We're going to multiply by the derivative of u. In this case, u is 3x squared. So we're going to get that y prime is going to be negative sine 3x squared times 6x. So our derivative is going to be negative 6x sine of 3x squared. Now parentheses do matter. Okay, they do matter. Because in this case, for our second one, cosine of 3 is going to be a constant. Okay, you can plug that in, it's never going to change, it's always going to be cosine of 3, whatever that is. We're just going to take the derivative of this. Okay, so we're going to end up with cosine of 3 times the derivative of x squared, which is 2x. Okay, we're going to end up getting that y prime is 2x cosine of 3. Okay, should make enough sense there. Next one is the one that people might get a little bit wrapped up on. The big thing here, you have cosine of 3x, that quantity squared. So what I want to do first is I want to bring this down to everything and get rid of that exponent. Okay, if I can avoid using the chain rule, let's go ahead and avoid it. Okay, so I'm going to have cosine of 9x squared. From here, my u value is 9x squared. I'm going to get that y prime. Derivative of cosine is negative sine. I still have 9x squared on the inside. I'm going to multiply by the derivative of u. And I'm going to go ahead and get derivative of u is 18x. So I get negative 18x sine 9 of x squared. That's my derivative there. Okay, last one on this page here. Let's go ahead and use color. Let's use black. Okay, so I have y equals cosine squared of 3x. Now, a big thing we have to know here is what cosine squared of 3x actually means. It means that we have the quantity cosine of 3x squared. Now, in this case, we're going to have two chain rules. So if I use my y prime, I'm going to bring this 2 down. I have 2 times cosine of 3x. The power would be 1 because you subtract 1. But now I have to multiply d of dx by the derivative of cosine of 3x. Now our derivative of cosine of 3x is going to be something like we were just doing over here. So derivative of cosine is negative sine of 3x, and then we're going to multiply by the derivative of the inside, which is 3. So this is going to be negative 3 sine of 3x. Now we're just going to go ahead and replace this up here. So that we get that our y prime is going to be 2 cosine of 3x times negative 3 sine of 3x, and we're just going to multiply so that we get that our y prime, 2 times negative 3 is going to be negative 6. We have cosine of 3x, and we still have sine of 3x. And that right there is going to be our derivative. Okay, we've got one more problem left. I know it's been a while. Just going to wrap this up here. This one's probably going to throw some people for a loop. Shouldn't be that bad though. So we've got y equals the square root of sine of 4x. Okay, I'm going to rewrite this like we do every time with the square root and raise it to the half power. I've got sine 4x to the 1/2 power. Now we're just going to do a double chain rule here. I'm going to get that y prime. I'm going to bring this 1/2 down. It's 1/2 times sine of 4x to the negative 1/2 power. Okay, and then I'm going to multiply by the derivative of sine of 4x. Our derivative of sine of 4x is going to be cosine of 4x times 4, which gives us 4 cosine of 4x. So we're just going to replace this now. We've got y prime is equal to 1 over 2 times, I'm going to bring this into my denominator, 1 over sine of 4x to the 1/2. Okay, went from negative to positive when I moved it from my numerator to denominator. And I'm going to multiply this by my derivative of sine of 4x, which is 4 cosine of 4x. So I'm going to get that y prime is equal to 4 cosine 4x over 2 square root of sine of 4x. And I'm going to simplify this 4 and 2 to give me my final answer, which is going to be 2 cosine of 4x over the square root of sine of 4x. Alright folks, that's all I had for you today. Thank you for your time. If you have any questions, please don't hesitate to email me or write on the Google Classroom. Thank you very much. Bye.